In this video, we'll explore three limits using tables. For this first function, f of x, as x approaches 0, the blue dots appear to be converging on approximately 0.01. And if we look at the table values, we see the same thing. So it seems fairly good to say that this limit is probably close to 0.01. For g of x, these green dots, looking at the table values, they seem to be getting pretty close to negative 0.911. Not sure what the next digit will be, but feel pretty confident about the negative 0.911. For h of x, the purple dots, the information seems a little bit spottier, but it looks like, the x values are definitely converging towards 0. They're getting smaller. And it looks like all the outputs are getting pretty close to 0. So 0 seems like it should be a fairly safe bet. However, when we look at this side, we can see that the exact same function was used to generate the table values for f, g, and h. What do we notice that's going on here? Here we see the green dots, the purple dots, the blue dots, but they're all converging to different values. And if you look at the function, we're really not sure what's going on. So you should take this as a cautionary tale about trusting a finite number of data points to inform our understanding of a function. The data points cannot be trusted to give us all of the information. So when we're using tables to evaluate limits, we need to be careful. Pause the video here and explore this function near x equals 0. You can zoom in, zoom out. What do you notice? What do you wonder? Let's explore what's actually going on with this limit as x approaches 0. And so I'm going to start by zooming in. And we notice that the lines are kind of feeling closer and closer together. We kind of have this wall of red that doesn't really seem to be doing anything. So if we zoom in, we're not actually getting too much help here. It can be a little bit challenging to see what's happening. So zooming in isn't actually helping us. In fact, the closer we get to 0, the more chaotic the overall behavior seems to be. So now let's go look at the function maybe and get some insight there. Looking at the formula for the function, we notice that if x is 0, we can't divide by 0, so this function is actually undefined at 0. But we know that the limit could still exist, so that's not enough. But let's explore deeper. So as x gets smaller, because we're dividing, x will fit into pi more and more times. In other words, as x approaches 0, pi over x will become larger. Pi over x will approach infinity. One way to interpret this with regards to sign is that the closer we are to 0, the oscillations increase in frequency, and the function jumps from positive to negative values faster and faster and faster. There is not a single output number that we can approximate as accurately as desired by making x close enough to 0. In fact, the closer x is to 0, the more wildly the outputs vary. In situations like these, we say the limit does not exist, and we might actually write the letters D and E to express this.